Question 11g. By factorising, or otherwise, solve 2 sine cubed x plus 2 sine squared x minus sine x minus 1 equals 0 for x greater than or equal to 0 and less than or equal to 2 pi. Factorise the left-hand side by grouping in pairs. We have 2 sine cubed x plus 2 sine squared x, which forms the first pair of terms, and we have minus sine x minus 1, which forms the second pair of terms. Now with the first pair of terms, we can factorise out 2 sine squared x. So that can be written as 2 sine squared x outside of sine x plus 1. And with the second pair of terms, we can factorise out negative 1. So that becomes minus sine x plus 1 in brackets. So to complete the factorisation, we can write this expression as sine x plus 1 in brackets multiplied by 2 sine squared x minus 1 in brackets. Next, we solve the equation in factor form. So we're going to solve sine x plus 1 in brackets multiplied by 2 sine squared x minus 1 in brackets equals 0. And for this equation to equal 0, either one of these two brackets or both need to equal 0. And this can be split into two cases. So case 1, we have sine x plus 1 equals 0. Subtracting 1 from both sides, we get sine x equals negative 1, and therefore x equals 3 pi over 2 radians. And for case 2, we have 2 sine squared x minus 1 equals 0. Adding 1 to both sides, we get 2 sine squared x equals 1. And dividing both sides by 2, we get sine squared x equals half. And then taking the square root of both sides, we get sine x is equal to plus or minus the square root of 2 over 2, or plus or minus 1 over the square root of 2. So this means that there are going to be 4 angles. So we're going to have an angle in each quadrant. So when sine x is equal to positive root 2 on 2, that's quadrants 1 and 2, so x equals pi over 4 and 3 pi over 4. And when sine x is equal to negative root 2 over 2, x equals 5 pi over 4 or 7 pi over 4. Combining the solutions from both cases, we have x is equal to pi over 4, 3 pi over 4, 5 pi over 4, 3 pi over 2, and 7 pi over 4.